Okay, cool. So welcome to the Learning LaTeX tutorial that UUG is putting on. We are excited to do this mostly because as math grad and undergrad students, we recognize that almost everybody at some point needs to learn how to do LaTeX, but almost nobody ever has any formal training. You just kind of end up like trying to do some things, finding some stuff online. So we're hoping that today we can kind of get over the initial hump of learning LaTeX and some of the very basic commands just to get us able to compile files and maybe get started on your path of forever learning LaTeX. So I think what we'll start with now is just a little bit of background on LaTeX, and then we'll talk about how to get started with what we're going to do today. So LaTeX initially was made in the 70s, and the version that we use was made in the 80s. And essentially, it's just a typesetting software. It's very convenient. A lot of the things that you can do in LaTeX, you can do in like Microsoft Word. So you can like typeset equations in Microsoft Word, for example. But there are certain things that you can do in LaTeX that you can't do in Microsoft Word. One thing to note is that it's LaTeX. For whatever reason, people hate when people say LaTeX. A lot of people say LaTeX too. That's like, I don't know. The first time I learned it, it was LaTeX. So that's what I'm going with. So the first thing that we need to do is go to overleaf.com. So I'll put a link in the chat. I guess it should just be fine. So go to overleaf.com and make an account. So we're going to be doing this in Overleaf today. And a lot of people, the first time that they learn LaTeX, actually learn it in Overleaf. And the reason for that, there's like several kind of nice things about Overleaf. So A, it's very easily accessible and you don't have to download anything. Another nice thing about Overleaf is that you can work on projects with partners on the same file at the same time without messing each other up. It's also pretty forgiving as far as compiling goes. So for example, what I do LaTeX on now is a local compiler. And if there's something wrong, it just won't compile at all. But so make an Overleaf account. I just always use my NCSU Google account and just create my Overleaf account with Google. And you should get something pulled up that kind of looks like this, except you'll have none of these projects. You'll just have a new project button that kind of sits in the middle of the screen. So yeah, let me actually just share that whole desktop because that'll be better. Cool. So you can see my Overleaf area, right? And I should mention, if you have any questions during this at all, feel free to use the chat, or you can raise your hand and we can like call on you. So you're going to have this this Overleaf page, and you're going to have a thing that says new project, right? And we've actually created some files that we're going to upload or that you're going to download and then upload today for this new project. So go to our website in the other resources tab. I can throw that in the chat real quick. And there you will find exactly one link that says learning LaTeX tutorial files. So you can click those and it'll download as a zip. So for instance, like it'll download as a zip. We'll just replace it. And we don't actually want to unzip this. So we want to leave it as a zip file wherever you download it. So we'll take just a little bit of time to do that. And the whole idea here is that the zip file is going to contain some example files, some helpful files, and then the main part of today is a tutorial file where Max is going to walk you through a tutorial of how to do some very basic LaTeX commands. So now that we have the zip file downloaded, we can click that new project button, and we're going to click upload project. So it's going to ask us to select a zip file or to drag a zip file. So in my case, I just have this zip file living in this like test folder that I made deep inside of my Google Drive. And so we'll just drag that zip file into the little area where it wants it. And it opens up this nice thing. And there's lots going on here, right? So the first thing it'll probably open is something we call the homework template. We'll talk about that more towards the end of today. You'll see lots of files. I guess there's 8 files over here. So 3 of them are .tex files, including the homework template, the LaTeX cheat sheet, and the tech along. One of them is a .bib file, and the others are PNG files. So we'll talk about what all that means in a little bit. Here's the basic layout of what a tech document looks like. So this is like a raw tech document here on the left side. And on the right side is your compiled version of this raw tech document. So this stuff on the left, all of this like typed out stuff that looks very codey, turns out into something like this on the right, which is kind of cool, right? This looks like every math exam you've ever seen or every math textbook that you've ever seen. Okay. So we'll just quickly go over how these files are kind of created. But for the sake of like today, most of this doesn't necessarily matter that much. So it always starts with a document class. There's several document classes that you can use. For the most part, you'll always use AMS art. There's other ones like report and book, but AMS art is AMS article class. And it's just like the best for just getting pieces of paper with tech on them. It also has some nice properties. There's other things you'll see in what we call the preamble. So this is the preamble, what happens before we actually start typing, called packages. And these packages give us access to several different neat tools or different typographical things that we like to use. We won't talk too much about these, but they're an important part of every tech document. There's things called new environments. We'll talk about those a little later too. There's some theorem-y things in here. There's some new commands, so you can write your own shortcuts, which we might talk about a little bit later. And then we get down to where we actually start the document. It has to start with a /begin document. And then at the very end, there's an end document. So that's kind of the basics of a tech file. And you'll see, we'll go into the tech along now. And at this point, I'll turn it over to Max to kind of go through this tech along with you. What I will say too, before, as we get this like transition started, is that so I am a 5th year grad student, and I've been doing tech for, I guess, like 8 years now or something. And you never like know everything about tech. So the learning curve at the beginning is very steep just to understand how to compile and things, but you never know anything, or you never know everything, and you're always going to kind of Google things. So we're hoping today just to get us over that initial learning curve. And yeah, so if you have questions, use the chat. Otherwise, I'll give it to you, Max.
All right. Hey, everyone. My name is Max, and I'm an undergrad math major. And I have only been using LaTeX for about a month, about a month, I'd say. And like Cash said, no matter your experience level, you're still prone to making a lot of mistakes. And also, I remember a month ago just overcoming this huge learning curve that is getting started in LaTeX. And so what I'd like to introduce y'all to now is the tech along file. So you'll click on, oops, let me share my screen. All right, you'll click on the tech along.tech file right here. And then you'll notice that you're viewing this LaTeX along file with a bunch of examples and then a bunch of source code in between, a bunch of text. And then at the bottom, you'll have challenges. If you're already an experienced LaTeX user and you think that you know most of this stuff, then you can switch over down here to the challenges below and then try writing these out. You can try this integral and its corresponding antiderivative. You can write out these Maxwell equations, or you can write out the sentence using logical operators. So we'll switch over to the rookies over here, and then we'll get started with number 1. So for number 1, I want y'all to scroll down on the source code all the way down to line numbers, let's say line 114. Okay, I want y'all to type your code in line 114. What I want y'all to do is type out an inline equation. And an inline equation is basically this example I'm highlighting right here. Oop. Right here, try typing an equation surrounded by dollar signs here. And then you write out an inline equation by typing specifically $y equals mx plus b, for example. And then Overleaf will automatically create the other dollar sign for you so that you can type in between them. Sometimes it does get annoying if you're used to other software, but you'll get used to it over time. And we can compile this. And then you'll notice on the side here, it types out this nice sort of italicized equation. And that is what this code here in dollar signs will translate to once you compile it. And inline equations are usually used for shorter equations that you are fine with referring to over and over again. But otherwise, if you're tired of writing out the same equation over and over again, you'll end up writing out equations separately, like in the example number 6 here, but we'll get to that in a bit. Let's move on to number 2. You can quickly refer to different common sets of numbers, like the set of all natural numbers or the set of all reals, all rationals, all all complex numbers, you know. And you can use comparison symbols like greater than, less than or equal to, etc. And then you can try writing out this code here, also surrounded by dollar signs right here. So dollar signs, to reiterate, just means math mode. Like whatever you're writing in between the dollar signs will be translated, like LaTeX the compiler will understand that it's all math, and it'll compile it into a neat style like here, so that the readers can recognize that it's math. And notice here, if you type out, let's type it out together, see? \nn subset EQ ZZ EQ All right, let's compile this. All right, we skipped a line here. Oh no, it just moved on to the next line here, but you see that here the natural numbers, the set of all natural numbers, the set of all integers, the set of all rationals, the set of all reals, the set of all complex numbers, and you'll see set comparison symbols used to compare these sets to one another. Moving on to number 3, You can also type fractions using the frac command with a bunch of braces, well, just two sets of braces in front. So then you'll use \frac braces, and then let's try to write out 1/2. So right here, this is written out as a fraction 1/2. This is simple enough, but it can get you can get a bit lost when you're writing out complex equations like in the integral down here. So be sure to, when you're typing out your code, be careful to use the braces properly and remember which braces correspond to which functions. Also, I forgot to mention, notice here that in number 2, in \NN and \ZZ and all these sets of numbers, these are actually not the actual commands for these numbers or for these sets of numbers. They're actually shortcuts. So how you make these shortcuts and why you'd make these shortcuts in the first place is to shorten how many characters you type per piece of code. So you can look all the way over to line 73 to line 78. You'll notice the command /new command /zz /mathbbmz. So this is basically redefining the command for the set of integers. So you'll do, so the original command is /mathbbmz, but then we defined it as a new command and shortened it to /zz. And this is common notation just specific to math majors who use this, or mathematicians who use this, because we often use these sets. And it's very convenient to use these shortcuts. Then we'll move on to number 4. Sometimes you might want to center your math, either because it's too tall to type inline or because you want to emphasize its importance. You can center your math by, once again, putting it in math mode, aka creating these double $signs, and then writing it out like this source code right here. So we'll copy that exact source code. So $, begin P matrix. And then you'll notice it's going red, but that's okay. You're still in the middle of typing it out. And then we're going to define a matrix here. And then close it with the double $signs. And then we're going to recompile. And you see right here, you got a centered 2x2 matrix over here. And it makes it much more neat than just having the code not be centered. So let's just have it without the $signs, and then just use the regular single $signs, and let's see what happens. There, it ends up being stacked next to the source code here, and so it's kind of hard to differentiate between the two. And it looks all cluttered and disorganized, and we don't want that. And once I fix this, we'll be moving on to number 5. All right, so you can also use the align command to several centered equations so that you can not just center like one matrix, but also, like, let's say a system of equations here. So I'm just gonna copy and paste. And then, of course, This does not need to be surrounded by $signs because the begin and end already tells the compiler that what's going inside is math. And so the $signs here are unnecessary, and the begin align and end align space here will center and align everything you have in there for you. And then we'll move on to number 6. All right, you can also reference centered equations from your text, but first you have to label them. So this is where you're going to have to decide whether you're going to use inline or type out equations like this. So let me copy and paste. I'm copying and pasting, but I recommend you all to type it out just to practice. Okay, let me compile this first. Okay. Notice how there's a number 1 here in parentheses. This indicates that you used the begin equation and end equation command here. And then you can also notice that, yeah, you wrote out the equation, but what about the label here? Well, the label does not actually show up after you compile it onto the page here. What the label does, it's just there for you to refer back to it. And by refer, you use an actual command /ref, short for refer. And so we'll do this right now. See how, whoops. There, I'll put it here. See how there's whatever label you put here has to match the reference here so that the compiler knows that you're talking about that same exact equation. And doesn't seem to look right. Oh, it's probably just a space error. Yeah, there you go. This one here matches up with this one here. We didn't exactly type 1 as the label in the source code, but it shows up as 1 because this is the first equation that we write out using this begin equation and end equation command. Oh, whoops, I was supposed to type it out here. See, sometimes you get lost in your own source code, and that's okay. You just have to take your time with it and then recompile and recompile over and over again. It never hurts to compile because that's how you can check if your LaTeX document looks correct. And we'll move on to number 7. Now try some other common commands. Try in centered math mode and inline math mode to see the differences. So we've already seen some differences in between them. Like inline can be fit in between text, while centered equations are between like paragraphs of text rather than being able to be fit into a sentence. So let's just try out different examples of symbols and commands that you'll use in your math homework, most likely. So let's try out these set symbols here. Once again, I'll copy and paste, but I encourage you to type them out on your own so that you get practice. All right. So you'll see here that I entered this double backslash. The double backslash just means that whatever comes after starts at a new line. And then I did this to just make this neater. And then so you can see a bunch of sets being manipulated with set symbols. And let's move on to the limits so we can try these out. And I'll start it on a new line. So the double backslash comes into play here. Okay, so you have limit of x
I think you need an underscore after limit there.
Sorry, what?
I think you need an underscore after limit.
Oh yeah, there it is. See, even we make mistakes here. Okay, recompile. Oh, it's not exactly underneath. Cash, what do you recommend?
Yeah, so this is the inline limit notation so that it fits in a line. Try the like centered math notation of it.
Center math. Okay, yeah. So we'll take out what we'll do. We'll take it out of math mode by removing the single dollar signs. And then we'll use the /begin braces equation command. And then notice how it'll type out end equation for you so that you don't have to. And then you just put your equation into here between the begin and the end. And then we can see the difference here. It's much neater for these limits. There, it looks much nicer here. Yeah, so you can see the limit is from x, the limit of x squared as x approaches, sorry, the limit of x squared plus 2x as x approaches 3 is 15. And then you'll notice here that we had an initial issue with the underscore. The underscore just means that it's under, in the case of the limit, it means it's under the limit and it defines the limit. But in the case of, like, let's say another variable, like, let me make a new line here, x underscore braces 2. Then you'll see here, you'll have a x and then subscript 2. So it basically means subscript in any other context generally. And then let's try out summations and binomials. So here we'll use the inline form since it's in dollar signs. And notice here, again, we're having this issue with the I equals 1 not appearing under the sigma, and then the n not appearing above the sigma. So what we can do is switch it over to centered mode. So we'll write, once again, begin equation. And then you'll notice that once you have begin brace, opening brace EQ, it'll sort of like suggest for you begin equation, end equation. So you just press enter and it'll type it out for you. And you can copy and paste here. Oh, I think I missed the subscript again. See, there you go. And then here you have this nice summation of I. And then we'll move on to modulo arithmetic. So I'll just rinse and repeat, copy and paste. So certain commands might require certain packages. So I'm trying to, let's see if we have
Just recompile it and see if it works.
recompile it. Okay. Because we should have the package AMS math here. So let's see. Okay, there it is. Let me put it on a new line. Okay, it's not centered because it's still an inline math mode. So then you have P modulo Q is congruent or is equivalent to R. And then we can rewrite that in centered form if you'd like. So then we get rid of these dollar signs. Then you do slash begin, opening brace, EQ, enter. Get rid of that dollar sign. And then compile again. And then boom, you got it centered. And you can refer back to it by, let's call it slash, let's label it equation mod. And we can write out a sentence here like an example of modulo arithmetic is, not that one, slash ref. We're gonna reference that equation. So slash ref EQ mod. And then we'll compile. And then you have it written out right here. An example of modulo arithmetic is equation 4. There you go. Yep, equation 4. Since slash ref just gives you the reference number right here. All right, and from now on, we have these challenge problems. We're not going to go over these, but you can attempt these problems on your own. In my experience, I had to Google a lot of the commands for a lot of these. So like for like how to do an integral, how to do a large parentheses, how to do square root, how to do arc sine. A lot of these I did not know when I first started and was first told to write an integral similar to this. But Google can help you a lot, but also we have another option to help you out with these challenges, and that would be the LaTeX cheat sheet. And so I click on the LaTeX cheat sheet here in the far left side of the screen. I switched from Tech-along to LaTeX cheat sheet. And then what we're going to do is recompile so that we can see the cheat sheet. And here, this guide to LaTeX will cover almost all the fundamentals you need to know as an overleaf LaTeX user. So you're explained here, like inline, how to write out inline mathematical expressions, and then even insert images. So like, for example, in the Tech-along file, let's recompile and go back to that one. Over here, this integral here is an image. These two Maxwell equations are images, and I made them images so that you can't cheat and look at the code here just to get the answer. So what I did was I uploaded an image here by clicking upload here, and then dragging an image from my documents onto here, so that it uploaded right here. So that like integral.png, this is the integral. This is the Faraday's law. This is, sorry, Faraday equation and Ampere's equation. Now let's go back to the LaTeX cheat sheet. And then you'll be given a list of a bunch of symbols that you might want to use when you're trying to do homework in LaTeX. So like you can go through all of these on your own, but this guide, when I found this, I would see myself constantly referring to it in the beginning. Nowadays, not so much, since you get kind of used to it over time. The more you use LaTeX, you kind of memorize a lot of these. But it's very useful to refer to every now and then when you're stuck trying to center something or write out a specific Greek letter, or something very specific. You can probably find it here. And then you're free to use this cheat sheet or quick guide to help you write out your homework in LaTeX. And in your upper, maybe MA 225 or MA 400 level classes, you might want to try out writing out your homework in LaTeX. In fact, I believe in the 400 classes, you might even be encouraged or sometimes mandated to use LaTeX. But this will come in handy, and then it'll definitely be a lifesaver for you in the beginning. But then over time, I recommend just getting used to it, trying out LaTeX on your own, and then you'll find yourself memorizing a lot of these. And so you might be wondering what will it look like writing out your homework in LaTeX? Well, I'll hand it over to Cash so that he can explain it to you.
Yeah, so this is a little bit overwhelming because there's just kind of a lot. There's a lot going on, right? So, like understanding how to compile an individual equation is fantastic, but there's a lot that kind of goes around that that's really necessary to be able to like actually make one of these documents, right? And that's why we've given you this file called homework template. So in the left-hand side here, you can see something called homework template. You can click that. We'll compile it. And it has a lot of nice features. And if you ask anybody that uses LaTeX how they do it, especially for something like homework, they'll tell you that they have the same kind of preamble for everything that they do. And they just kind of copy it over from document to document, right? So that's kind of the idea of this file here. You can see it's kind of set up. You can decide if it's a homework or an assignment. You put your number, the class, and your name. In this document, we've actually created specific problem and homework and solution environments. So you can see over here, this begins a problem environment. This will tell us what number it is. And then you type out what the question was. So in this case, show that the set of 2x2 matrices of rank 1 is not a vector space of C2 by 2. And then there's also a solution button environment, which just kind of gives you this like little solution thing. It's also nice just to be able to like find the solution for a particular problem because you know it's in between these two solutions environments, right? Also, we populated this file with some things just so that you could see examples of other things that you can do in tech that we didn't necessarily talk about today. So we talked about matrices a little bit, the begin P matrix thing, right? We talked about integrals, we talked about aligning, and we talked about limits, right? We also talked about summations, which is cool. One thing we didn't talk about were piecewise functions, but it is on the cheat sheet about how to write a piecewise function. Once you get more adept with LaTeX, you can do kind of pictures like this through something called TIC-Z. So here's just like a quick example of how to do that. And then as Max was mentioning, you can insert images from online into your LaTeX file too. So here's an example of how to do that. And then kind of the bane of most techers is BibTeX. So you can actually automatically generate a bibliography with LaTeX. And we did just a quick one down here at the very end of my advisor's textbook because that's what I knew off the top of my head. So that's useful if you do like a longer project and you need to reference some things, or when you write your first paper. So again, this file is kind of just designed to be your template that you're going to use. So you can delete everything in here up to this kind of problem one area. It's probably how I would start it, right? And then start typing your own problem one, start typing your own solution. Just above problem one, you can see where you put the due date. You can see like the class and your name and the homework. And then you can kind of start making this file your own. So if you're really tired of typing particular things, you can write out new commands like Max was talking about. So there's a few down here that are common, like rank and dx and ddx. But overall, I think like the most important thing to know about LaTeX is that you're always going to be learning. You're probably always going to be Googling how to do certain things. And like no one's really that great of an expert, especially around our age. So just always kind of mess with it. And really all that matters is that in the end, it looks like what you want it to look like. Your source code doesn't really matter that much. So with that, I think we'll close this. Thank you, Max, for the great tutorial. Otherwise, yeah, have a fantastic rest of your afternoon.